Welcome, dear viewers. Today's lecture will be about galaxies, more specifically about normal galaxies. What is a galaxy? A galaxy is a massive gravitationally bound system that consists of stars and stellar remnants and interstellar medium of gas and dust, and an important but poorly understood component called dark matter. The name is from the Greek root Galaxias, meaning Milky Way, a reference to the Milky Way galaxy, which is our galaxy. Typical galaxies range from dwarfs with as few as 10 million of stars up to giants with 1,000 billion stars. In any galaxy, all the stars orbit around the galaxy's center. Our Sun is just one of the billions of stars in the Milky Way galaxy. In today's talk, we will focus on the different types of normal galaxies, as we are going to see on the slide right now. You can see among the most distant galaxies in the universe. You can see different types of galaxies like elliptical galaxies, spiral galaxies. In today's talk, we're going to see the different types of galaxies, especially normal galaxies. We're going to talk about spiral and barred spiral galaxies, elliptical galaxies, lenticular galaxies, and irregular galaxies. You can see the most distant galaxy, which has been imaged by Hubble telescope in the universe. It is found at a distance which is about hundreds of billions of light years from us. On the next slide, you can see one of the deepest fields taken by Hubble telescope. We can see galaxies at the early stage of formation. We call them protogalaxies. Now, all our knowledge about galaxies is due to different types of telescopes. Most of us know optical telescopes, which is using visible light as the main part of the electromagnetic wave to see objects in the universe. But nowadays we have very sophisticated telescopes which work at different frequencies, like radio telescopes, infrared telescopes, ultraviolet telescopes, X-ray telescopes, gamma ray telescopes. All those telescopes came into existence only since the last 50 years. And thanks to all those new telescopes, our knowledge on galaxies has increased enormously. Next, I will show you some pictures of those telescopes. On your screen right now, you can see a gamma ray telescope. Now you can see an X-ray telescope. Now, X-ray telescopes cannot be placed on the surface of our planet because the X-rays will be distorted by our atmosphere. That's why X-ray telescopes are found on satellites which orbit our planet. You can see the picture of an ultraviolet telescope, which is also found on satellites. In the next slide, you can see an infrared telescope. Infrared telescopes also are found on satellites due to distortion in the atmosphere when infrared light reaches the surface of our planet. One of the most important type of telescope is the radio telescope. You can see the Parkes radio telescope, which is found in Australia. It is one of the first radio telescopes which has been used by astronomers to investigate the radio universe. Now, most of those radio telescopes are found in an array. You can see 3 dishes which form part of an array of radio telescope. And it is found in Australia. It is called the Australia Telescope Compact Array. One of the most fascinating telescopes is the Arecibo radio telescope. An interesting part of this telescope, as you can see on your screen, you just follow the cursor, it has been built in an existing natural crater. So they have used a natural crater to put the dish, and just above the dish we have something called the feed, where all the energy which is incident on the dish will ultimately focus on the feed. This is one of the first radio telescopes which has brought a wealth of new information in astronomy. Now let's look at the classification scheme for galaxies. Most galaxies can be classified as elliptical galaxies, spiral galaxies, lenticular galaxies, or irregular galaxies. As you can see on your screen, just follow the cursor, we have different types of elliptical galaxies. An elliptical galaxy looks just like a rugby ball. Now, if you follow the cursor on the screen, you can see a lenticular galaxy. A lenticular galaxy looks just like a grain of lentil. Galaxies can also be classified as spiral galaxies, as you can see, follow on the cursor on the screen here. This is a spiral galaxy, which has a nucleus and arms with different prominence. Now we have different types of spiral galaxies, like if you look at the cursor here, there's some kind of bar, or even here you can see it better. There's some kind of bar at the center of the galaxy. So the spiral galaxy has a bar at the center. It has its usual arms. They look just like pictures of cyclones which we take from satellites. So the barred spiral galaxies and the spiral galaxies are among the most common galaxies in the universe. Now let's look at pictures of different types of galaxies. This is our Milky Way galaxy. Obviously you will ask yourselves, how can we take a picture of the Milky Way galaxy? This picture has been made from a simulation of data obtained from different telescopes. So from the simulation we can see the Milky Way galaxy. And if you follow the cursor at the center, you will find some kind of bar. That's why our Milky Way galaxy is called a barred spiral galaxy. And in the picture, you can also see the approximate position of the Sun in the Milky Way galaxy. Let's look at a few more pictures of spiral galaxies. So again, it's our Milky Way. This picture is very blurred because this picture has been taken near the center of our galaxy. It's very difficult to get pictures which are very clear at the center of our galaxy. So it took us nearly 50 years to build sophisticated telescopes to be able to find out what do we really have near the galactic plane and the center of the galaxy. If you follow the cursor on the screen, that white patch is mostly stars within our galaxy. But just above them, they need not be stars. They could be other galaxies which have not been imaged with sufficient resolution and sensitivity. Next, I will show you a picture of the nearest galaxy to us, which is called the Canis Major galaxy, which is around 25,000 light years from our galaxy. If we take a picture of all galaxies in the universe, we'll see that most galaxies would have interacted among themselves to some degree. There are some galaxies where the encounter has been so violent, like here. This is our galaxy, Milky Way. After the encounter with the neighboring galaxy, you can find a residual path, which is, as you can see on the screen, that reddish and pinkish path, which is left after the encounter. It is thanks to the observation of this encounter that we can conclude about the existence of the Canis Major galaxy. The next nearest galaxy to us is called Sagittarius galaxy. What you see on the screen, if you follow the cursor, it is the effect of the interaction of the Sagittarius galaxy with our galaxy. Now, if we look at the sky anywhere in the world, we have only 3 galaxies which we can see with our naked eyes. One of them is a large Magellanic Cloud, which is an irregular galaxy. As you can see on the screen, it does not have any particular shape. This is one of the closest galaxies to our galaxy. We also have the small Magellanic Cloud. It is also an irregular galaxy. It does not have any particular shape. So besides the first 2 galaxies which I mentioned, the small and large Magellanic Clouds are among the closest galaxies to our galaxy. But the closest galaxy which has a very peculiar shape is the Andromeda galaxy. It is the closest spiral galaxy to our galaxy, and it is around 2 million light years from our galaxy. Let's see some more pictures of spiral galaxies. So we have around 100 billions of spiral galaxies in the universe, and no 2 spiral galaxies look alike. It's a bit like if you take all human beings, each one of us has a particular fingerprint. So similarly, each spiral galaxy has a particular characteristic, has a particular specificity. Now, the way we see spiral galaxies in the sky depends on its orientation. Suppose my hand is a spiral galaxy. Suppose we are looking at it straight like that. you will see a particular shape. But we can have some spiral galaxies which we look at edge-on. If you look at the spiral galaxy edge-on, you might not see the spiral. I will show you now some pictures of different spiral galaxies with different angles of orientation. So in the next slide, you can see the pinwheel spiral galaxy, because it has the shape of a wheel. That's why we call it spinwheel. Now this galaxy is very funny. As you can see, it looks similar to a whale. That's why we have given it the name whale galaxy. So this whale galaxy is actually a spiral galaxy. Let's look at some more spiral galaxies. So in this spiral galaxy, the bar, as you can see on the screen, if you follow the cursor, is very prominent. This is a typical barred spiral galaxy. Now this spiral galaxy, we are looking at it edge-on. Because it looks like a needle, we call it a needle spiral galaxy. This is a very interesting picture, which has been taken when the moon was just in front of Andromeda Galaxy. It's very rare to be able to take such a picture. So on your screen right now, you can see on the left a spiral galaxy, and on the right a lenticular galaxy. A lenticular galaxy is like in between spiral galaxies and elliptical galaxies. As I said in the beginning of this lecture, a lenticular galaxy looks like a grain of lentil. This is a very nice looking galaxy. It's called the sombrero galaxy because it looks like the hat of a Mexican, like the sombrero, famous sombrero hat. This is actually a spiral galaxy. Again, because we are looking at it edge-on, we won't see the spiral arms. Now let's look at elliptical galaxies. So on your screen right now, you can see, like if you follow the cursor, a few elliptical galaxies. Elliptical galaxies look just like rugby balls. I'm sure you must have seen a rugby ball, which is very elliptical in shape. So all those are elliptical galaxies. Elliptical galaxies are very different from spiral galaxies. The main difference between spiral galaxies and elliptical galaxies is that in elliptical galaxies, most star formation has already finished. Whereas in spiral galaxies, star formation is very livid, and we can see a lot of stars being formed in different hydrogen regions in the spiral galaxy. Now you can ask yourself, did galaxies always exist? No, the answer is no. Galaxies did not always exist. So what you are seeing on the screen right now are called protogalaxies. They are the initial stage of formation of galaxies. So in this initial stage of formation, we cannot tell exactly what shape it has. As you can follow the cursor on the screen, all those are protogalaxies which have been taken by the Hubble telescope. So what you see on the screen now is a region of hydrogen in the universe where protogalaxies are being formed. As I said, it is an early stage of formation of galaxies. This is a picture which shows one special effect in physics called gravitational lensing, where you have a cluster of galaxies in front, the protogalaxies are behind. So strictly speaking, we cannot see directly the protogalaxies, but because the light bends around the cluster, we can see the protogalaxies. On your screen right now, you can see two spiral galaxies which are interacting. If you look at the early universe, most galaxies have had some kind of encounter. So right now you can see two spiral galaxies which are encountering. So you have one here, and you can see the connection here. So there's some kind of bridge between them. Actually, when you have two spiral galaxies interacting, it's like a cosmic dance. It's a bit like you find a couple doing some kind of ballroom dancing, and ultimately, after a few billion years, the two galaxies can merge into one single galaxy. And there's a theory in physics which says that it is possible that whenever two spiral galaxies merge, we have an elliptical galaxy which is formed. Just like stars, galaxies come together due to the gravitational force, and form clusters of galaxies. What you see on the screen right now, if you follow the cursor, are different galaxies which have been brought together by gravitational attraction. So whenever we have galaxies which come together so close, we call them clusters of galaxies. This is another cluster of galaxy, named after Hubble 1689. Hubble was a famous astronomer who discovered many clusters of galaxies. That's why we have many clusters of galaxies whose names have Hubble and some number followed after it. So if you follow the cursor on the screen, you can see different galaxies. So whenever we have the density of galaxies is very high, we say we have a rich cluster of galaxies. This is another cluster of galaxies called the Virgo cluster of galaxies. If you follow this cursor, you will see the different galaxies which are found in Virgo cluster. And Virgo cluster is among the closest cluster of galaxies to our cluster of galaxies, which is called the local group. Now, this cluster of galaxies can be imaged at different frequencies using different telescopes. So right now, you have an image which has been taken from an X-ray telescope. So whatever you see on the screen right now is not visible to the eyes. Whatever you see on the screen, whatever color, each color represents some amount of energy which is emitted by that X-ray cluster of galaxy. Like here, the white will be the highest energy, then you have the yellow, then red and blue. Now, if you take all those clusters of galaxies, again due to gravitational attraction, all those clusters of galaxies come together to form what we call superclusters of galaxies. So what you see on the screen right now is a supercluster of galaxies called the Coma supercluster. So you have, like here you have a cluster, here you have another cluster, here you have another cluster. So all those clusters come together to form a supercluster of galaxies. And if we look at all galaxies in the universe, we see that we have hundreds or billions of superclusters. If you look at the screen right now, dear viewers, you need not worry what is written on the screen, but all those white patches which you see on the screen are actually superclusters of galaxies. So that's a picture of the whole universe when looking at visible light. Now, if we want to find out about the distribution of galaxies in the universe, here I have 4 different pictures. At the bottom right of the picture is a universe which we see which is very close to us. So all those dots you see here on the screen are actually galaxies. Now if we go slightly further in the universe, that's what we see. If we still go further away in the universe, that's what we see. And if we still go further away, that's what we see. So ultimately, all the galaxies seem to be found on some kind of soap bubbles which are stuck together. I'm sure all of you must have been playing with soap bubbles when you were young. So when you have all those bubbles together, you have inside the bubble it is empty. It is like a void. And all those galaxies are found at the surface of the soap bubbles. I'll show you another picture which gives you the distribution of galaxies in the universe. So if you look at here, they look like some kind of filaments. The black spots are voids where you don't have any galaxies. So all those galaxies are found on those filaments or surfaces which look like soap bubbles. There are more than 200 billions of galaxies in the universe. From the latest data obtained from different telescopes, it looks like nearly 50% of galaxies are spiral galaxies and nearly 50% are elliptical galaxies. The big mystery is whether the elliptical galaxies form first or spiral galaxies form first. Now, some astronomers believe that spiral galaxies have been formed first, and because of fusion between different spiral galaxies, elliptical galaxies have been formed. In astronomy, we have different schools of thoughts. So you have different groups of researchers. They have different opinions about the origin of different objects in the universe. As I said, some believe that spiral galaxies form first, but you do have another school of thought which says that spiral galaxies and elliptical galaxies have been formed independently. There has never been any collision between them. But whatever is said has to be supported by observation data from different telescopes. It has to be supported by gamma ray telescopes, X-ray telescopes, infrared telescopes, ultraviolet telescopes, optical telescopes, and radio telescopes. So all the telescopes which we have on our planet right now have certain limitations. So what kind of limitations do they have? They have limitations in resolving power and sensitivity. So it's only when we are going to build more sophisticated telescopes that those differences can be sorted out. So far, those different groups of researchers in astrophysics, they stand on their point and they don't want to change. Now let's look at the picture of a spiral galaxy again, which you see on the screen. So a spiral galaxy has a nucleus, just like our galaxy, and it has arms. If you follow the cursor, you can see the different arms. Now, why do those arms look so bright? It is because you have stars, and you have regions where stars are being formed. You also have regions where stars are exploding, which are called supernova remnants. So whenever a star explodes as a supernova, the amount of energy which it emits is enormous. So we can see a spiral galaxy because of the billions of stars which are present and what is happening near the galactic center. There's one thing which most astronomers agree is there could be a black hole, a supermassive black hole at the center of each galaxy. Now, what happens with a black hole? The black hole has such a huge mass, which is nearly like infinity. It absorbs all the matter in its vicinity. So whenever it absorbs matter in its vicinity, energy is being liberated. So as you can see on the picture right now, that's why you have so much of energy which is being emitted from the center of the spiral galaxy. So basically, a spiral galaxy emits energy because we have a lot of star-forming regions, and the main activity is star formation. So stars are being born in some regions, the stars evolve with time, some of the stars explode like supernovas, and they emit a lot of energy. But if we look at an elliptical galaxy, as you can see on the next slide, elliptical galaxy, compared to the spiral galaxy, it does not have any particular core. And you don't see any spiral arms in the elliptical galaxy. It looks like a homogeneous distribution of matter. So that's the main difference between elliptical galaxies and spiral galaxies. Another difference between elliptical galaxies and spiral galaxies is, as I said, in spiral galaxies, most of the energy is being emitted due to star formation and stars dying like supernovas. In elliptical galaxies, most of that star activity which we have in spiral galaxies are over. So the rate of star formation in an elliptical galaxy is much less than that in a spiral galaxy. You do have some stars which are being formed, but the rate of formation is quite low. So why does an elliptical galaxy emit so much of light? It is because of stars which are already existing in the elliptical galaxy. And some astronomers believe that at the center of an elliptical galaxy, the supermassive black hole is much bigger or has a much higher mass than the mass of the supermassive black hole at the center of the spiral galaxy. So the activities happening at the center of an elliptical galaxy is still a mystery to many astronomers. But we believe that most of the energy which is being emitted by an elliptical galaxy, it is due to the activities occurring around that huge supermassive black hole at the center of elliptical galaxies. Now we have a few percent of galaxies which are called active galaxies. What we observe from the data from different telescopes which I mentioned earlier, nearly 99% of those active galaxies are elliptical galaxies. You have a very small percentage of active galaxies which are spiral galaxies. If you look at the next slide, so here we see two spiral galaxies which are interacting. Before understanding this slide, one should know that the universe is expanding. So as we go backward in time, the density of galaxies was very high. So you had many galaxies which are very close, like on your screen. Two spiral galaxies are colliding to form most probably an elliptical galaxy. Dear viewers, to conclude, let me say that our knowledge on galaxies has increased enormously during the last 80 years, thanks to all the sophisticated telescopes. But our telescopes are still limited in their resolution and sensitivity, that there are still a lot of information about galaxies that are yet to be known. The more we know about galaxies, the more we realize that there is still much more to be known, like how galaxies have been formed, how galaxies evolve with time. I hope that this lecture has given you a basic idea about what galaxies are. Thank you, dear viewers.